Number 1. Stopping light. Light is the fastest thing in the universe, traveling at a speed of 300,000 kilometers per second, and nothing can slow it down, right? Theoretically, yes. However, in practice, scientists have manipulated this rule. In pioneering experiments, researchers from the University of Darmstadt managed to stop light completely inside a special crystal. They used a technique called electromagnetically induced transparency, where they fired a laser beam into a cloud of cooled atoms and then turned off a control beam. This effectively trapped and froze the light in place. When they turned the beam back on, the light emerged as if it had never stopped. The ability to store light represents the cornerstone for building quantum internet networks, which require storing and processing information carried via light. Number 2. Time crystals. Physics has long told us that perpetual motion is impossible and that nothing can move forward without energy. However, in 2012, physicist Frank Wilczek proposed a radical idea. What if there was a substance that repeated its pattern not just in space, like a diamond, but in time as well? At first, the idea seemed like science fiction that defied the laws of thermodynamics. But the major breakthrough occurred recently in 2021, when researchers from Cornell University and Google partners used quantum computers to create time crystals. These materials change their state and return to their original form in an endless cycle without consuming any energy. This opens the door to a completely new generation of stable quantum memory. Number 3. Mind reading. Reading what goes on in another person's mind was once considered magic or sorcery, but today, science has turned it into a reality that is both terrifying and astounding. Using a combination of functional magnetic resonance imaging and advanced artificial intelligence, researchers at the University of Texas have succeeded in translating brain activity into written text with high accuracy. The experiment did not require any brain implants. Instead, participants listened to stories while AI decoded their brainwaves to write a precise summary of what they were thinking. In another experiment, scientists were even able to reconstruct images a person was looking at solely by reading their brain signals. However, despite the precision of this research, it still faces obstacles that keep it far from everyday use. It requires the voluntary cooperation of the individual, as the device cannot read thoughts unless the participant is fully cooperative and focused on specific ideas, since any mental distraction immediately confuses the AI and causes the translation to fail. Furthermore, the massive equipment remains a major barrier, as functional magnetic resonance imaging machines are bulky and extremely expensive, making it currently impossible to fit this technology into a hat or a portable device for use in our daily lives. Number 4. Converting light into matter. We are all familiar with Einstein's famous equation, E equals mc squared, which implies that matter is essentially condensed energy. While nuclear bombs have proven that matter can be converted into immense energy, can this process be reversed? Can we take light and create solid matter from it? For decades, the Bright-Wheeler process remained a theoretical concept proposed in 1934. It suggested that if two photons collide with sufficient energy, they would produce an electron and a positron. This was long considered practically impossible, requiring laser power equivalent to that of stars. However, in 2021, scientists at Brookhaven National Laboratory successfully demonstrated this experimentally, using the relativistic heavy ion collider. They managed to observe pairs of matter and antimatter generated solely from the collision of electromagnetic fields, achieving this fundamental cosmic alchemy in a laboratory setting for the first time. Number 5. The unsinkable metal. Through a unique bio-inspired innovation, scientists at the University of Rochester have engineered unsinkable metals that remain buoyant even if damaged or punctured. This technology mimics the air-trapping abilities of diving bell spiders and fire ants. Using ultra-fast femtosecond laser pulses, researchers etched intricate microscopic textures onto aluminum and steel surfaces. This etching creates a protective air layer known as a plastron, which completely prevents water from adhering to the metal. This advancement relies on structural buoyancy, a design that positions two treated surfaces face to face to create a cavity that shields the air inside. ensuring the metal stays afloat even after long periods of immersion or severe scratching. Furthermore, these surfaces possess self-cleaning properties that prevent biofouling, thereby reducing drag and saving energy. This achievement paves the way for a new generation of ships and marine structures that defy sinking and endure the harshest environments. Number 6. Gravitational waves. A century ago, Einstein predicted that violent events in the universe, such as the collision of black holes, are so powerful that they do not only affect matter, but actually shake the very fabric of space-time, much like a stone thrown into a pond. He believed that detecting these ripples would be impossible because they are so minuscule, smaller than an atomic nucleus. However, the LIGO Observatory achieved the impossible. Using laser beams spanning 4 kilometers, scientists detected a faint vibration caused by the collision of 2 black holes that occurred a billion years ago. This discovery did more than just prove Einstein right. It granted us a new sense of hearing for the cosmos. We are no longer just seeing the stars, we are now hearing the violent collisions of the universe. Number 7. Communication during lucid dreaming. Dreams are an entirely isolated world, aren't they? When a person falls asleep, they become disconnected from the world. However, scientists from several countries have collaborated to break this barrier. They focused on lucid dreamers, those who are aware that they are dreaming while they sleep. In a remarkable experiment, researchers managed to conduct a two-way conversation with people while they were dreaming. Scientists posed simple math problems, such as 8 minus 6, to the sleepers via audio communication, and the dreamers were able to answer correctly from within the dream by moving their eyes in a pre-arranged pattern. This proves that reality and dreams are not separated by an impenetrable wall as we once thought, and that consciousness can maintain a connection with the outside world even during its nightly journeys. Number 8. Antimatter trapping. Antimatter is matter's evil twin. If they touch, they instantly annihilate one another in a massive burst of energy. For this reason, containing it was long considered impossible. After all, how can you keep something in a container that explodes the moment it touches the walls? At CERN, scientists managed to create a highly specialized magnetic trap that prevents the antimatter from ever touching the sides. They successfully trapped anti-hydrogen atoms for more than 16 minutes. While 16 minutes might seem like a short time, in the realm of quantum physics, it is an absolute eon. This breakthrough has allowed scientists to study the properties of antimatter for the first time as they attempt to solve the universe's greatest mystery. Where did all the antimatter go that was supposed to have been created during the Big Bang? If you liked the video, don't forget to subscribe to the channel and share the video with your friends. Thank you for watching.